So this tutorial is going to explain inheritance. You can find it in the article below, linked this one, where I explain all the different kinds of things that you can do when you are inheriting. So what we've looked at before was encapsulation. So instead of having all the properties of your class public, we made them private. So we actually said specifically, if you remove the public word in front of the property of the class, it will be defaulted to private. But we did this. We said they're private, and then that meant that we were not able to directly access that property. If I try to do that, I said car dot. There's no access to that vehicle directly. We have to go through getter and setter functions, get current speed, get top speed. And that's the principle of encapsulation. So just to recap on that, there are 3 access levels of encapsulation. There is public. So if I set this to public, that means that anyone is able to access and change this variable outside of the class, right? And then there is protected. And this comes in. Comes a bit clearer as to what this means when I explain this principle of inheritance. But if I leave these as private for now, and then I show you the issue we'll get later. But basically, protected and private mean that they're not accessible outside of the class structure. So what we're going to do now is we're going to take vehicle, and I'm going to extend it because there are different types of vehicles. There are cars, there are lorries, there are aeroplanes. And if I write class car, and then I do colon, and then I say vehicle. Now we're going to inherit all the properties of vehicle, but we're going to add some extra things that only cars can have. So let's imagine that cars have the only things that have heated seats. So that's true or false. And then we have to create a constructor. The constructor initializes the properties of your class. And we have to create a constructor for car. And the constructor for car needs to pass in all the properties that we have up here, P top speed and current speed, plus the extra property heated seats. That's a Boolean, heated seats. And then what we need to do is we need to call something called base. Base is going to pass back P top speed and current speed to the parent class, i.e. vehicle, because vehicle has a constructor, this one, that initializes these properties for us. It initializes current speed and it initializes top speed with these values. So we don't need to repeat this code down here. We can just pass them back up, or in some languages, and especially in OCR language, it's called super. So super will pass back up the variables to be initialized. But we do need to initialize heated seats. So I'm going to use this keyword, which refers to this property of our car. This dot heated seats equals heated seats, like that. So this is our constructor of class. We've got a new property, heated seats. We have to pass in top speed, current speed that we then need to pass back up to vehicle, plus the extra one, heated seats, and we need to initialize that. You could also imagine that car has its own specific abilities or functions. So we can add in those functions, those behaviors to car as well. So let's say car has one called turbo boost, and turbo boost will increase our current speed by quite a lot. Now we want to access turbo boost. We don't want to directly change the current speed, but we could just call the accelerate function that's in our parent class. So we could say call accelerate and then pass in quite a large number. So car now has an extra property, heated seats, and then it has an extra function, an extra ability. So back up in our main function, instead of creating a vehicle that's of type vehicle, we're going to create a vehicle of type car, and we're going to call that Mercedes, and we're going to say new car. Then you've got top speed, current speed, and then have we got heated seats or not? Let's say true. So we've got this extra property that will be passed into our car constructor. And then we need to change the object here as well. So I've used the word car, but I'm going to change that to Mercedes, all these different places. I'm just going to delete less. So we've got a few less examples. So, and here as well. So we can still call the function accelerate because that's in the parent class to car vehicle. And we can still call decelerate because it's in the parent class to car. But we've got this extra property, which is, do we have heated seats or not? So I could access that extra property by saying Mercedes, the object, dot heated. Well, I can't actually access it because, why? Because I've made heated seats. Well, this is actually private. So I'd need to create a getter and a setter for heated seats. So public dot bool, we're going to return heated seats, get heated seats, and then we're going to return heated seats like that. So I'm going to now be able to access it through this getter function, get heated seats, and then I can print out whether or not we've got heated seats in our vehicle. So what we've done here is we've taken our base class vehicle and we've extended it to have a different type of vehicle, a car, and given it some extra properties and an extra function. The next thing I want to show you how to do is there are some things that vehicles have in common with each other in terms of their behavior, such as accelerate and decelerate, but how accelerate and decelerate is implemented varies. So what we can do is we can make this accelerate function in our vehicle class. We can make this something called virtual. And then instead of implementing accelerate, we're going to implement it in each of our types of vehicles because we want accelerate to be different depending on what kind of vehicle we have. So I'm going to take this code and I'm going to go down here and what I'm going to say is I'm going to say public override. So like in this example, in the animal example, I'm going to say public override void accelerate. And it auto completes it for me. And actually what it's doing is it's calling up the functionality in my base class speed. But say if I wanted to do a completely different implementation of what accelerate means, I'm just gonna paste that code in here that I copied. And I'm going to accelerate in a different way that the car would to any other vehicle, because you can imagine an aeroplane is going to accelerate much faster than a car. So I'm going to get rid of this speed thing as well, and I'm just going to add on 20 because a car will probably be able to accelerate at about that rate. There's a couple of errors here which I'll explain in a minute, and I'm also going to change this as well. So I'm going to say accelerate is just an empty function with no parameter, and the actual meat of the function vehicle classes such as car. Now the problem is current speed is inaccessible due to its protection level. Well, what is the issue here? Well, the issue here is that we've made it private. So remember, there are three types of access levels: public, accessible by anyone. We don't really want to do that unless we have a very good reason. Private is only this class vehicle will be able to get and set these properties. But if we make it protected, that means that that class and its subclasses will be able to change and get the value of it. So that's what we're going to do. We're going to make both current speed and top speed protected, and then it's going to get rid of this error down here where we're overriding accelerate and we're changing the current speed which is defined in our vehicle class. So obviously you could do this for decelerate. Why don't you give that a go? And then maybe you can think about maybe creating some other classes that you could change, that you could inherit like from vehicle as well. So we could have class aeroplane, and that extends vehicle. Let's give aeroplanes a number of wings, right? And then we'd have a public aeroplane constructor. It would take, I think it's top speed and current speed, and then the extra property wings in its constructor. And then we need to pass the common properties back up to our parent class, our base class, which would be top speed and current speed. And then we need to set wings in our child class, aeroplane. And now we could override accelerate in our aeroplane class and do this in a different way, because obviously an aeroplane is going to accelerate at a much faster rate than a car. So we can add on, say, 200 miles an hour per second. Well, that's probably a little bit too much, maybe 100. So it can accelerate much faster. So what we've done here, just to quickly recap, is we've got our class vehicle. We've changed our common properties of our class vehicle to be protected, so they're accessible by the child classes. Then we've changed the accelerate function to a virtual function and done no implementation of it, because our child classes, car, which will extend vehicle, will implement accelerate in its own way, because it will accelerate at its own speed, as aeroplane does as well. And then the two types of vehicles, car and aeroplane, they differ. Aeroplanes have wings, so that's an extra property, but cars have heated seats. And in the constructor for car, we need to also pass in common properties, top speed, current speed, and heated seats. But also in the constructor for aeroplane, we need to pass in top speed, current speed, and then just the new property wings, and then implement accelerate in a different way. And that is the principle of inheritance. So why don't I have a look at the article and make sure you understand this example with vehicles. Try and do the example with animals, where you have to implement different types of animals and then make them have different types of functions to make sounds. And then have a look at maybe creating a furniture class, and then one for calculating areas of shapes, employee classes, and then finally there's a past paper question at the end. Okay.